Hey, hello everyone. Today we're going to go through some of the most frequently asked examination questions in H2 Chemistry, in specifically for GCE A'level examination syllabus. So the highlight for today is Reagent Chemistry. Now we are looking at one of the most frequently asked examination questions. So the first one is the year 2012, paper 3, question 1c. So basically this reaction is trying to tell you that you have a benzene ring react in the presence of Cl2 and a catalyst. You will exchange the H here to become a Cl. That's why they call it a substitution reaction. Second, why is it the word electrophilic? Because it's driven by an electrophile. So we take a look at the reaction breakdown, how exactly this has taken place. So the first step of the reaction is the Cl2 will react with the catalyst here. So this Cl and this Cl must be the same, and the Cl will be pulled away to form Cl plus and AlCl4 minus. So this is an electrophile. Second step, the benzene ring will attack the Cl plus and you form your target intermediate. Then finally your AlCl3 will actually react with acyl chloride the same way, then to form the product. And so that's what the question wants you to do. So let's take a look at part number A. So for part number A here, we have a benzene ring reacted with acyl chloride. So this is the acyl chloride here in the presence of a catalyst to form your target product. So before we move on further, we have to understand how is this acyl chloride looks like. So the acyl chloride actually looks like this way. So let me just draw it out. It looks like CH3, C double bond O, and a Cl group. Alright, so we go through the same mechanism. You see, this one got a Cl here. This one got a Cl here. So the Cl will be pulled away. Just like the step that you see above. Cl, pull above one Cl to form Cl plus. So you form one intermediate. So the intermediate here will look like this one. So let me write down I represent the intermediate. So you form CH3, C double bond O, and a positive charge. So this is the electrophile. Then what will happen next? Next is the benzene ring will attack the electrophile to get substituted. This is what the reaction is trying to tell you. So we're going to draw the benzene ring. Then don't forget that only one of the position will be attacked. So I just chose here. So attack, you form C double bond O, then followed by CH3. Now, it's very important to stress that this is the carbon that's being attacked. That's why the benzene ring must be attached to the one that's carried the electrophile but in no other position. So this is basically your product A. Right? Very straightforward, very similar to the reaction above. Now let's take a look at the second part. So let's call this as part 1 and call this as part 2. Now part 2 is going to be a bit more challenging. So this is where we're going to draw the mechanism out. So let's see and visualize very carefully what is going on. So let's take a look. You have a molecule here in the presence of AlCl3 and you form a single product. So this kind of reaction is to be strange. Why is it strange here? Because this one got two reactants react in the presence of catalyst, then you form the final product. Now it's like you only have one reactant in the presence of a catalyst, so how does it react? So normally if you see only one reactant react in the presence of a catalyst, so you must remember that it's likely going to be what we call an intramolecular reaction. So let me show you how the mechanism breakdown looks like. So you have three different steps. First step here is you draw the benzene ring, you draw a circle in the center. Now, in Singapore, when we draw the benzene ring, you always draw the cyclohexane with a circle in the center to represent the delocalization of electrons. If at different parts of the world, maybe you will see 3-alkene instead. Okay, so depending on syllabus, but this is for respect to H2 chemistry in Singapore syllabus, so we draw a circle in the center. Then after that, you will draw the compound, double bond O, and a Cl in the presence of AlCl3. Now, do you should remember the earlier part of the mechanism? The Cl will pull away by this AlCl3. So the same thing also applies to here. This Cl will be pulled away by this AlCl3. So you will form to this intermediate. So let me draw out the intermediate here. And a plus charge. Then followed by AlCl4 minus. Alright, so you form this one. Now, as you know, this plus charge is not very stable. This is what we call the electrophile. So what will happen to the electrophile? Will be attacked by our benzene ring. So the next step here is you do a nucleophilic attack to this carbon atom. Then you will form the next step. So let me just draw out. So you draw this one. Then followed by you do intramolecular reactions. So intramolecular reaction meaning that this carbon here, all right, this carbon must be adjacent. Okay, cannot be this carbon, this carbon, this carbon, this carbon. Must only be the adjacent directly carbon. This carbon is fine as well, but I just prefer here. So you join to here. Then what we're going to do is we're going to do a ring numbering technique. And let me show you what I do my ring numbering technique. You're going to number the ring accordingly. So for example, this is the first position, second, third, fourth, and you join to this position, the fifth. So some of you may wonder, what do we mean by ring numbering? Because when you join this part of the carbon to this part of the benzene, you're simply forming a cyclic structure. That's why we're going to draw a ring out. And we know this is a 5-member ring, so we're going to draw a 5-member ring structures. So this is how the 5-member ring structure look like. Then the next step is you do the numbering again. This is 1, 2, 3, 4, 5. Now what we're going to do is we're going to match. We're going to find where's your double bond located. You notice the double bond is at here. So you're going to draw a double bond here. Then from here, okay, you compare the structures. So this is basically your final product. Right? Remember, this is the breakdown of how you achieve the final product. Very, very similar, right, to the earlier part of the reaction. This is the this is the catalyst, pull away the Cl, then followed by the nucleophile attack from the final product. Then what about this one here? So this guy here, you will actually pull away the Cl, then followed by you will form an electrophile. So this will go through intramolecular attack, but you must remember it must be the adjacent carbon. So you close a ring to form the final structures. So you label it 1, 2, 3, 4, 5. So this is a 5-member ring. Fourth position is C double bond O. That is the final product. So now let's take a look further on the next part of the questions. So it's question number 4, or question number B, sorry. So suggest the reagent and condition for a reaction that can be used to distinguish between A and your B. You should state out each of the A and the B which can react and draw the structure of the products if of any reaction that occur. So what I'm going to do is we're going to draw out the A and your B product first. So let's take a look. A, this is your product. You draw the benzene ring, C double bond O, CH3. Then you will compare directly with another one, which is B here, that we just discovered is a 5-member ring. So we draw 5-member ring and double bond O. Alright, so next step, how am I supposed to distinguish between the two of them? Alright, there's one method you can use. So for example, let me just write down this is B first, so there's no confusion. So you need to differentiate between these two. Now, what you're going to do is, you will notice that right, in this part of the ring structures, you see this one, C double bond O and the CH3. Alright, whenever you see this group appearing, okay, this is a very special group that is able to be detected by what we call an aldoform test. Okay, it's an aldoform test. So how does aldoform test actually being carried out? So basically this is the reagent condition. So let me write down the test. So the test here, what you'll be using is your I2 aqueous in the presence of NaOH aqueous, and you warm it. So what you will be noticing here is A will give you what we call the yellow PPT. Then your B here will have no yellow PPT. Now, what does it mean here? It means that aldoform tests only write very specific to a specific group. Like this case, you only recognize C double bond O, CH3. So I want you to imagine like something like dialing a number to a number log. So number log of 4 digits, right? So you key in the 3 of them correct already, 1 incorrect, you cannot have the answer. You cannot open up the log. So the same also applying to this specific reaction. Aldoform tests only detect this part of the molecule. So which means you only have this combination, then you can use this test to detect it. So you form a yellow PPT. Then some of you may wonder, so what is a yellow PPT? Now the yellow PPT, right, is your CHI3. Right? It is actually your trialdomethane. Okay, trialdomethane is a yellow product. Then followed by, you also need to write down the organic molecule. So this is what we call a step down reaction. What do you mean step down? You see, currently, right, you look at the side chain here, got 2 carbon. Now you lose 1 of the carbon. So that means how many carbon left? 7 carbon left. Alright, 7 carbon left, meaning that you need to include 1 carbon here and these 6 more carbon. Okay, so original is 6 plus 2 is 8. Now you're left with 6 plus 1 is 7. So we're going to draw out another product. So maybe instead of a comma, I put a plus here. So you draw a benzene ring and a COO minus. Now, why is there a COO minus? Because first thing, autoform test is also known as oxidation reactions. So which means that it will remove this carbon and together at the same time install COO minus because it's an alkaline medium. So initially they form a carboxylic acid. Then after that, the carboxylic acid react with NaOH to form COO minus. Alright, so this is the videos that I want to show you to you overall the most frequently asked examination questions. So like the videos, if you wish to see more such questions appear, more such a tutorial or maybe solution discussion in the YouTube video channels. So this is Dr. All here, we are signing off.